Bom dia a todos, então, pessoal. Dando prosseguimento às nossas atividades dessa manhã, temos uma plenária com o palestrante, Dr. Edivan Laercio Carvalho, com a sua palestra intitulada Power Electronics for Energy Efficient Buildings and Districts. Edivan Carvalho obteve a graduação, mestrado em Engenharia Elétrica pela Universidade Tecnológica do Paraná, em Pato Branco, em 2015 e 2018, respectivamente. Posteriormente, concluiu o doutorado em Engenharia Elétrica pela Universidade Federal de Santa Maria. Atualmente, Edivan é pesquisador pós-doutorado no grupo de Eletrônica de Potência da Universidade de Tecnologia de Tallin, é assim que se diz? Na Estônia. Seus interesses de pesquisa incluem topologias de conversores de potência de alta frequência, edifícios com energia zero líquida e sistemas de gerenciamento de energia. Então, obrigado por ter aceitado participar aqui, doutor Edivan. A palestra é sua.
Good morning for everyone. First of all, I'm quite happy to be here. As probably everybody knows, I'm a former PhD student from this university, and for me it's like it's a pleasure to came here a few years after like these years in a different positions. I was remember like during this week. My first Sepoc as a PhD student, and now is like is a pleasure to came here like in a different position. I'm really happy to be here. I will try to make my presentation a bit different from the last ones, because my interest here is like to show you our developments, what we are developing there in terms of I can't say like products, but in terms of prototypes, our group is like very oriented to development, to harder development. So I will try to avoid much as possible equations and these stuffs, like a very technical analysis. But I want to show you our main ideas about development. During this week, actually, we was talking a lot with you, with like different people, and I saw like a lot of curiosity to know what is happening in Estonia, how is life there, what the things are happening there, and I will try to make some like a very brief introduction. I also will be very happy if you get some interest, if you want to ask something, will be very useful in this sense. Estonia is like a very small country, comparing like to Brazil and other countries in Europe. We have only 1.4 million people, close to 1.5 million people, something like this. Is a small country, but in another way is very interesting in many senses. In terms of economy, I would say we have a very interesting thing, because the country in general is like oriented to technology development. And technology development in this case, in most of the cases, are related to software and apps or other stuffs. And that's why I'm citing here showing you some companies. Probably you know, or at least use it. Some of it, probably this one, you know, the Skype. Skype is like our showcase, or one of the success of Estonia, because Skype was like a tool developed in Estonia. It's a Estonian company, and the most interesting thing is was a software developed in my university. Now, after some years, this company was sold to Microsoft, but originally is an Estonian company. And in this sense, this is, of course, is like one case of success. And in this sense, we have like a lot of different cases in Estonia about it. And in some way, it starts to be a business. After get some this like startup development start to be a business in Estonia, So here I have like two interesting things. Estonia is like the leader in terms of per capita. Of course, we start comparing like population and size. Estonia is the leader of European Union in startups per capita, and also is the leader of unicorns, basically companies which achieve like a range of billion euros a year. So it's quite interesting. It's quite interesting how it is related to our group, because cultural and as I said before, it starts to be a business. There's a lot of investments in terms of even like from private and public investments in development about almost everything, about software, about hardware, about like different ideas. Here's the Tallin. This is the Estonian capital. We are not like a huge city like the Brazilian capitals, but we have like around 440,000 people. How is this is related to my speech today? I'm talking about high efficient buildings. However, we also have like this heritage, the old town. The Tallin Old Town is like a very nice place to visit. We are receiving a lot of tourists every year. Over the year, we always like receiving tourists. But if you can imagine, if you have like the old town is the UNESCO World Heritage. However, if you start talking about high efficient buildings, we are talking with like very modern things. And in this sense, this is also a challenge, because we have a very old, we need to preserve it. In another way, we need to also provide the solutions for it in terms of energy efficiency. If one of you have interest to have like I don't know, for curiosity, I'm including here this QR code. We will have access to this website. Visiting Estonia, there's a lot of informations, places to visit. Maybe some of you will get interest to move there and maybe work with some collaboration. Basically, currently I'm working in this university, Tallinn University of Technology. For the European standards, let's put it this way, is like quite a new university. It's around 100 years, but for Brazil is still kind of old university. Since 2018, we are changing a little bit. First was like we was operating with this name, Tallinn Technical University, TTU. But after some like reformulations and modernizations, since 2018, we are working with this new brand, TalTech. There's a lot of different courses there, more related to like IT, because as I said before, IT is like a very important for the country. The business development, and in my case, I'm working under this School of Engineering, this department, Electrical Power Engineering and Mechatronics. In this department, there's some research groups about electric machines, microelectronics, power systems, and our group is the power electronics group. Basically, we have currently we are working in different research topics related to electric vehicles, PV generation, and our main research topic is high efficient buildings. I will explain you why this is important, but the most important fact here is we was one of the founders of this Center of Excellence in energy for buildings. Of course, this is like a huge, is a national project, it is a huge project, and this is not only related to power electronics. We have like a part of civil engineering, like a thermal installation, other stuffs, and our part in this case is like to provide the very high efficient electrical installations for it. The group in general, we are working in more than 20 people. These numbers are fluctuating all the time because we have like PhD students who are defending, postdocs who are coming and back in home. We have like different people, but in general it's like between 26 people, between like postdocs, PhD students, and senior researchers. the annual budget of the group is like around 1 million euro for our size. Like for a country like Estonia is like a quite good number. I will put in this way. Just to show you, like we are like a real people. These are some faces of our group. This picture is still, as I said, is still changing, but in general, this is like our team. Here, this is like more or less like the structure of the group. The group leader is Professor Dmitry Vinnikov. He's like one IEEE member fellow. Why? He will have like a huge experience with PV converters, and also with some contributions with impedance sense converters. That's why he got like his IEEE member fellow. We have like other senior researchers like Andriy Chup. He's working with PV, also with PV converters, partial power converters, and optimizers for PV generation. Andriy Bidanov, who is working with battery and the EV chargers and the current FET converters. This is like one of his like achievements. We still using a lot of his developments in our group. Even me, I'm using some of his like strategies. And me, I'm like I would put in this way, I'm like the AC guy in the group. We are working with like a lot of DC developments, and I'm working with this interface between AC grids and DC inside buildings. Basically, this is what I'm doing, and this is like, let's put in this way my micro team. We have like some PhD students work with hardware development for AC-DC converters, with control system, and also one bit different strategies. Omer is one of the students from Norway. He is working with a single stage approach. Basically, it's an isolated single stage converters. I will also talk about it in this presentation. So why? Now I will try to explain why buildings for us is like so important in this way. First of all, even in this conference, we are discussing about like different topics, and I will put in this way: we are trying to electrify almost everything. We are trying to electrify applications for agriculture. We are trying to electrify like aircrafts. We are trying to electrify chips. So buildings in this case is still a very important thing. Here I'm including some numbers, how the electrifications are growing in different applications, and if you see buildings, we have like this prognosis around 2030, the share of energy consumptions in buildings will be like almost 50% in terms of electricity. These numbers could sound like a bit strange for most of you, because in Brazil we are using electricity a lot, but in Europe in general we have a lot of problems related to heat pumps and cooling, so there's a lot of gas using. So, however, the European Union in general, we are looking for some problems, and the European Union are delivering some directives in terms of how can we make it more green. How can we make it like the first neutral climate block around the world. This is like one of objectives of European Union, and that's why we have like a lot of projects in this sense. As I said before, we still have some challenges, because almost of our current buildings, they are not efficient, and of course I cannot say to you, change your house now. Change your house, just sell it and change and buy a new thing very efficient. Of course, nobody wants to do it. Everybody wants to buy a house and maybe to live there like all your life, maybe to give it for your next generation or something. So this is still a problem. We have some buildings to retrofit. Let's put it in this way. Here I have other informations about energy sharing. If you start to compare between different sectors, even industrial and transportation, buildings are one of the main sources of energy consumption, but not energy consumption, but also related to energy waste. And I also will explain it. We are we are consuming a lot of energy in buildings in general. Probably we are guilty in some sense. Probably some of us like forgetting our lights on and some stuff like this. And basically, we need like smart solutions for buildings. If you compare here, the average share of buildings of energy consumption in buildings in Europe is around 40%. Only in buildings is 40%, comparing these three sectors: transportation, industrial, and buildings. And we have a share of energy consumption of 40%. And in Estonia is a special case. We are going even more on it, achieving like 50%. So because of these numbers, the European Union are trying to create some directives how to improve the efficiency of buildings. Talking only, I'm not including here in industrial buildings, only commercial and residential ones. One of the main directives of the European Union is this one, the Energy Performance of Buildings Directive. And these directives has a lot of recommendations to follow and how to make it. Of course, we are in a power electronics conference. I'm talking more about electricity, but we also can talk about like cooling, hot air recovery, some other isolation, other stuff like this. But one of the main contributions of this directive is like the classification of buildings, the labeling of buildings. Everybody knows about labeling for equipments, for devices, and we also can apply it for buildings. We have exactly very well defined numbers. And here I just showing like two examples. If you are like in a G-class building, we have like a lot of energy waste. And if you have like a 1A class building, we have very low energy consumption. Why this is important? Just including here one example. Even if you want to buy a house, one flat, an apartment, or if you want to rent it, the companies, like the sellers, needs to show you these numbers, which is like the classification of these buildings. Why? Because in countries like Estonia and other countries in North Europe, it's quite difficult to plan your bills, basically. I put here like two examples for how it works in Estonia. This is actually a real measurement. We have around the country some measurements that we are using to make some statistics. And if you are including PV generation and considering this intermittence, it's quite difficult to plan like how we will pay it. In which sense? If you compare here in the summer, we have like a lot of generation, and our resulted demand will be even negative for like most part of the day. However, during the winter, we also have like a less generation and a lot of power consumption because we have problems with heating. So in the winter, we have like no generation and the heat increasing the power demand. And in the summer, we have like a lot of generation and almost no consumption. So what is the problem here? In the summer, I'm paying like 100 euros of bills, and in the winter, maybe I will pay 3-4 times more. So you as like in your family, how can you plan it? It's like quite difficult in this sense. What is one possible solution? So is these near zero energy buildings. The near zero energy buildings basically are based on the consumption over 1 year. If you have like we need to achieve almost zero energy consumption around the year, over the year. Basically, this is the idea here. To achieve it, of course, we need very high efficient devices, appliances, but we also need the local generation and storage. Basically, this is the idea, to generate energy, storage, and use everything on site. You see, this is also related to the people behavior. Nowadays, people want to be more and more independent. They want to depend less and less about the system operator. So this like generation and management locally starts to increase, and this is like even one push of these like current directives. Just to make you like a figure what's happening today. Everybody knows we have like a AC system for power distribution, but in another way we have a lot of power electronics inside these devices. Here I'm including one example with like PV generation, LED lightings, computers, air conditioners, home appliances. Could be like different home appliances, energy storage, EVs starts to appear in a massive way. However, what is the problem with this kind of installation? Of course, it's like easier to only install PV generation, storage, and use it. We already have an installation there. But my question here is like, how can we improve even more it? There are some methods we discussed in this conference how to manage it, but in terms of efficiency, like in terms of power losses, how can we do it? We need to develop different hardwares for it. Here including some numbers and to show you where is like the main problems of AC system today. Most of the problems are related to these rectifiers. Could be passive or active rectifiers, but we still need like these two power processing stages, which means there's a lot of energy waste in two senses. One is in terms of efficiency, and another one is related to the power factor. Just to could you roll? So here to give you one example, we have some measurements for two cases of applications. One is like a LED lighting, and another everybody have here this power electronics interface, laptop charger. And if in terms of power factor, have a very low power factor because of course no every appliance has power factor correction. If we still start to thinking about the only one lighting like this, maybe there's not too much energy. But my question here is maybe to provocate you. Start to thinking about a building like this one, or maybe like this university, and we start to increase this energy waste. How much will be the total energy waste in this case? Here is another problem, because with AC system we are generating our own problems. We start to generate a lot of, so we have like solutions for it, but in terms of reliability, we still adding additional complexities there. Complexities is one thing, but if we are thinking about sustainable solutions, we have more elements to fail. And we are creating basically the elephant in the room. Nobody knows how he's there. He's there, but nobody knows, and we are creating it. Our philosophy, let's put it this way, our solution is to use a DC for power distribution inside buildings. I know maybe you don't want to make a retrofit in your home now, but maybe for the future, if you start to use like a different solution, we can improve efficiency. Like step by step, we can improve efficiency. Why? Because with first of all, we have like this first installation AC with a lot of red lightings there, and but with DC we are reducing power processing stages. We are simplifying control. We have like no reactive power, means we have like less energy waste. And so this is like our main goal, to make it like a very green electrical installation. We still need this interface with the AC grid. I will talk about it in this presentation. We still need it because some people don't want to add energy storage. And in this case, we can use the AC grid, the power system, as one kind of energy storage, selling and buying energy. And also for power support to the grid, we need like this. It still needs this interface. But the idea in general is try to minimize it much as possible. If you can avoid this interaction with the grid, I will do it. Of course, we have a lot of challenges. This is like the general idea, but we have a lot of challenges. The main one is related to standardization. Currently, we have some standards under development. Our main reference is this one, NPR 99, was like the very first national practice guideline developed in Netherlands in 2018. So based on this guideline, there's some things is going. Currently, the main leader on this like initiative is this consortium of different companies. It's called Current OS. The Current OS are trying to do some protocols, some guidelines for DC electrical installations, for low voltage DC electrical installations, up to 1.5 kilovolts, basically. If you see here, there's a lot of known companies, and we are exactly here. As I said before, we was the very first academic partner of Current OS. Currently, we are trying to work in like many directives and to try to standardize DC systems. In terms of hardware design, I will try to. Of course, in the Current OS, there's like different protocols. I will try to highlight here, like the main things, how to develop, or at least the main things important for me, how to develop our hardwares. One thing is like because Current OS is already defined like industrial and building scales voltage levels. This is quite important. And another very important thing is like the compatibility between different power sources. This compatibility is based on droop control. That's why here we have like nominal voltages, and this range of voltages where we can operate under droop control. Basically, in this region, we have some freedom, but we need to operate under droop control to ensure like a compatibility between loads and sources. Here, this is like was a result of a lot of work. We did some work for like trying to revise the standards and try to propose something. And this is how the Current OS and also the NPR 99 are proposing to classify protection zones for buildings, not for buildings, but for DC electrical installations in general. Here, these protection zones are dependent on the voltage levels and current limitation, and also related to isolation. In terms of isolation, we have two classes of isolation. Maybe this is the most important one, because where we have like direct contact between loads and the end users. For example, your laptops, your smartphones, and these stuffs. However, we also need isolation between the AC part and the DC inside the buildings. Why? Maybe we can use like a common ground solutions where we have like no leakage current. However, how to ensure like this isolation between faults between DC and AC? So currently is like predicted in the standards this isolation. So we have like two classes of isolations for extra low voltage where we have direct contact with appliances and end users. So here we have like no risk with electric shocks. And here we need fault isolations because the interaction between AC and DC grid. We have some like previous publications where we try to make or try to indicate some standards, some previous standards to make this interface between AC and DC grid. In this, if someone has interest to check this paper, there's a lot of standards and directives discussed there. And also we try to propose some possible solutions to do it. The very first one is like to use a line frequency transformer. Basically, this is like the most simple solution. However, we need a low frequency transformer, which means a lot of costs, copper, and volume. And that's why now we are working with like a high frequency isolated converters. Basically, this is like my research topic. Here is like this is a very interesting figure, because here I'm showing in terms of functions what you need to do when you have one AC system and what you need with DC. If you see this like a grid interface converter in the AC, you have a lot of things to do, like over voltage and under voltage right through, anti-island protection, TGD. We need to take care about a lot of things. However, in the DC side, we just need a drip control, and it will work perfectly. This is the idea. This figure is quite didactic in this way to show how DC can simplify things. As I said before, we have some different measurements to try to make some statistics in terms of energy usage in the houses and buildings in general, residential buildings. Here, including one example, it is like a real example and with real data, and I will try to show you how the AC are creating problems for us. In Estonia, this is a quite common problem nowadays. If you see here, with PV generation, EVs and stuffs, we can have like an imbalance of power between phases. This is like a very good example. If you see the phase 1, always like overloaded, while phase 2 and 3, there's like almost not using. And what is the problem here? And why this occurs? If you see in this phase, for example, if we are installing a single phase PV converter, we can generate in one phase and consume in another one. And we are starting to creating problems for the system operator. We had a meeting like last year with the Ministry of Estonian Energy and Climate, and this was one requirement from the ministry to do some solutions in this sense, to how to compensate this problem, basically to compensate this problem. And we are trying to look for some power electronic solutions to do it. One of the solutions is based on 2 stages. We have one stage to work with the AC interface, and another one to provide isolation. This approach still has a problem. It still has a problem. Why? Because with 2 stages, we have like one converter losing energy here and another converter also losing energy here. Even if we can design it with in a very efficient way, this is a problem. However, also there's a lot of power electronics. There's a lot of power electronics still. However, this is quite industrial solution, because everybody knows how to work with an AC-DC converter, and everybody knows how to work with like a dual active bridge. They are quite industrial solutions. We also try to look for like a different alternative. I said before about single stage converters. In this case, we have like no intermediate DC link. We don't need these capacitors. We can eliminate all this part of this converter. And the result is we have a very compact prototype. However, when you start to think about this phase balance, this converter is quite complex. It's quite complex in terms of modulation. It's quite complex in terms of control, and it starts to reduce your degrees of freedom to work on it, to work with like very specific problems, as I said before. We did it. Here I'm showing like the converter topology. Is based on this like matrix converter with like bidirectional switches. And nowadays, probably you know, Infineon Technologies are developing these bidirectional and monolithic switches, and it could be some kind of advance for this application. However, as I said before, we have problems in terms of complexity. Even though if you see like the efficiency curve is quite good and quite flat. To eliminate this problem, currently this is our solution. As I said before, quite industrialized in terms of industrial acceptance. We have a 3-phase inverter with shared DC bus and the dual active bridge as the main guy for the isolation. This is like our solution. Of course, this converter should operate according to the current OS protocols. We have to discuss how to design this converter to follow the current OS protocols. In terms of buildings, we also have a problem because the energy usage. If we're thinking about like a conventional design, or maybe in terms of like the marketing of my company, they also want to sell the product with like the higher peak efficiency as possible. However, for buildings, this is not always true. If you imagine we have a building, a net zero energy building, with a lot of generation, and I want to increase my generation. I want to increase more and more and more. Basically, the result is this converter will operate with partial load most part of the time. This is also like some statistics that we made before in some papers. This is appearing in some of our papers. But in general, for buildings, maybe I not care too much about the peak efficiency at maximum power. However, I really need a very flat efficiency, and I need to ensure it at partial load. To solve this problem, as I said before, the AC interface, maybe you have like not too much freedom to work on it, but maybe with the DC-DC converter we have it. Here I comparing like different solutions. If you are going to like a resonant approach, we did it. If comparing both like dual active bridge and a series resonant converters in terms of components, in terms of how they work, there is like not too much difference in terms of complexity. But we have some specifics that we can analyze to compare both. Here I would like to introduce a more technical thing is related to effective operation area. For like a normal converter, we always try to define like an operation area where this converter should be designed and it will work. However, for buildings, we have not exactly an effective operation area because we are limited because of the drop control requirements. So maybe here we have one specific line to follow. We have a line, not an area. And it can be included in our converter design. This was the idea. It was one paper published in the Transaction in Industrial Electronics last years. And this was like our methodology. In terms of dual active bridge, I will try to explain you why these requirements are affecting the converter efficiency. In this case, if you compare, this is like the power transfer equation. This is the only equation I will use today. I don't want to overload you with a lot of equations. But this equation is important. Here we can see how like the leakage inductance affects this angle to transfer the same power. And these two figures are showing how if we are increasing this angle, we are generating a lot of reactive power, even with DC. Even with DC, we have some reactive power. However, operating under drop control, maybe we don't need to over push these limits to achieve like a wide soft switch range, because we don't need it. We are not falling in a area. We are trying to work under a line again. So this was like basically the methodology that we developed. And here we have like some experimental results which are proving that operating under drop control, the dual active bridge can ensure soft switch for a wide operation range. This was the idea. And we are comparing like these both solutions, the series resonant, where we have like a full soft switching, and the dual active bridge. The interesting thing here is analyzing the specific requirements for this application. We don't need to waste a lot of money to develop a hardware with maybe the most expensive switches. Here I'm including like two designs. We did it and we measured it to see how can we select the semiconductors basically. And with this approach, with this design, we can even use the dual-active bridge without overload my costs. This is a second approach. Actually, now we are publishing this paper in the Sobra app in our local journal. I'm quite happy to do it because it was like my way to how to share like my research in the national community. I'm quite happy to do it because this was our solution. Try to include this additional part again to follow the current OS protocols, to follow these like isolation requirements with a single devices, and maybe in the future we can improve it for these cases, for a generic case where we have like a different interfaces with USB devices. You know, USB starts to be more and more common, and maybe in the future I will not travel anymore with a charger. I will travel just with a wire, and I will charge my laptop and I will charge my smartphone. In terms of development, we are like a quite active group. Let's put it this way, we are a quite active group. And we had this idea, the Residential DC Innovation Hub. Basically, this is our main project, let's put it this way. This is our main project. What we are trying to do? We are trying to use this small building, very small building, to create a real showcase. So this was the very first DC building in North Europe. We have a lot of different projects in Netherlands about DC, even with public applications. But in North Europe, this is like the very first proof of concept. So our idea is try to develop our one hardwares or one solutions, install there, and make like in real time measurements and generate data for the society. Thank you. Thank you. Here, if you see, just let me back here. We have so like these facade PV panels. We have different arrangements of PVs in the rooftop, and inside the building you have like energy storage and loads. Here is like one scheme. What we have there. We have like 350 volts of distribution and one isolated converter, and basically whatever we are developing inside the buildings is based on DC. Yes, we are trying to follow the current OS protocols. We have some protection devices, USB interfaces for different appliances like coffee machines, vacuum clean, different things. We are trying to do it, like laptops, computers, other things. And basically this is our living lab. This is one interface where we are trying to visualize this data that we are generating in real time, and we are trying to work inside. In this shelf we have our prototypes as showcase. We have some prototypes working in this living lab, and we have some samples to show for some visitors. We are trying to invite people. We are trying to invite normal people, like investors. We are trying to invite companies to come to us to discuss, to see how they can test their devices in our buildings. This is another thing. We have some industrial partners where they are trying to test with us their devices, and we are trying to develop our own devices. Here I will show some of our very last developments. We are always trying to sell it in a kind of a commercial way. This is the FlexiVerter. The idea of a FlexiVerter is operating as a Lego. I don't know. I'm like a nano producer, and I don't know if I want to install a battery or a PV or maybe both. And this converter will identify if they are operating with a battery or with a PV, and will follow the current OS protocols. So basically the idea here is to generate a system like this. If I want to add a new thing, I already have this converter. I just will just add a new converter. New converter will be battery, will be PV, and it will work. just to be more technical, this is like the converter topology, and the idea here is to work with like a topology morphing control. The main researcher in this area, like the project coordinator is Andriy, and the responsible is our PhD student Salman Khan. We have this another project is a quite nice one. The idea was to create this cube, and all like the components like these like most volume components are included inside cube. This project is called Force, fractional power converter, but in the papers you will see it as a partial power converter. The partial power converters, this is a quite interesting idea, and the idea is to process only the energy that we really need to control a process. For example, in a battery, maybe we don't need to process 350 volts. We can just process like this delta to control the charge processing. For this project in general, this is quite important for us, because if we are talking about green solutions, second life batteries will play a very important role. We have like EV chargers, we have EVs in general. We are using these batteries, we are deteriorating the batteries, and after this we cannot only forget it in some corner and not use it. So the idea here is like try to use for a second application, maybe for a third application, and we're still trying to keep it green as much as green as possible. Let's put it in this way. The responsible for this project is again Andriy, and who is like the project coordinator, and the responsible is like Nilesh Yadav, our colleague Nilesh Yadav. Now we are recruiting a new guy. Probably you know Newton. Newton will move to TalTech in the next months. We are quite happy to add him in your team. And he also will work in this research topic. We also, this was a project we are delivering with the Qatar Foundation. Was a project selected for Qatar Foundation 2 or 3 years ago. Was a EV charger based on a very nice topology. It's a current fed topology. I can show to you here. And the idea here is to use like a current fed solution to provide basically we can have like different kinds of solutions in this AC/DC interface. However, with this current fed, we can simplify a lot this charger. Why? Because if you imagine a three-phase charger with a current fed, we can only use like 1 or 2 inductors to make like this power factor correction. This is quite nice in terms of a cost saving. And also we are working with some circuit breakers. The main responsible here is Satish Naik, our partner. He is working in the Indian Institute of Technology in Darwa. And he's the main responsible for like this protection. Protection is still very challenging for DC. Because if in some way drop control can simplify a lot in terms of energy management, the coordination, and what we can do with this is like quite complex. You have like problems of like soft starting and like short current detection, and so we also have like a research area in this topic. My outputs for you in this sense, how can we move for like a more green solution in terms of buildings, in terms of efficiency? I'm like highlighting here like 3 topics. The first one is like the public acknowledgement. We need to like advertise more and more to make it more for people more familiar. Maybe your grandmother will not know about power electronics, but if you can talk to her and say that with this new solution we will save his energy cost, maybe these people will stop to listen to you. Of course, international standardization is the most important thing. We need well-defined standards. Hopefully, in the future, we'll see even in this country, national prices guidelines for these new installations. And we also need like more maturity in terms of technology. We need like converters for DC, we need the chargers for DC, and we also need appliances which will work only with DC. In our group, we are developing this non-profitable organization. It's called i3DC. With basically it means inform, inspire, and innovate. And it was one of the ideas. How can we advertise DC? And basically our developments are under this like a non-profitable company. As I said before, I was trying to do my presentation in a different way because I really want and I will be happy to interact with you. So I will finish my part, but I will be very happy to talk with you now.
Thank you for your presentation. And DC for inside the house is a really hot topic. I remember when I was doing my doctorate sandwich, I think that's the way that we say, that we are, the group in the University of Oviedo was researching converters for LED applications that works with the idea that you showed us here, that you don't need to step up all the voltage, you just need that delta V to increase and to control the LED current, because the LED as well as the battery, it has a behavior of a voltage source, so you don't need to do that. And I am a professor of electrical circuits too, and when I explain to my students like what is AC and where we use it, and they understand like for distribution why we have to use the AC, but when I start to explain where we use AC in our home today, it feels like we shouldn't use it, because like in our AC, for example, our AC has an inverter, but you have to convert it first to DC, to then convert it to AC to change the frequency. Like your TV, it works with DC. Your mobile charger, it works with DC. And like many other applications, the LED lamps that we use today works with DC. So it's a really, really interesting topic to explore, and I think we will see a lot of changes in this field. So, any questions? I will start with Ademir. No? Who? No? Lucas?
About the isolations. It has a lot of isolations in many places. The slide that shows the isolation between AC grid and this
Yes.
isolation between the AC grid and DC internal grid.
Yes.
And then there is the isolation between the internal DC distribution and the 48 volts. Okay, 48 volts for safety, user safety, without
It's quite good,
to be a low, very extra low voltage as safety measure.
Yes.
But the main DC distribution, why couldn't be used RCDs,
Yes.
residual current devices with B-type residual current devices, and isolate the faults, the ground faults, instead of isolation.
Yes, I will put in this way. Why EV chargers needs isolation?
The same way, yeah.
Yes, it's the same thing. Maybe in the future we will see these standards changing for like non-isolated solution. Who knows? But for a while, at least the industry are feeling more comfortable with isolation solutions. This is the truth. If you can use like an isolated converter, as I said before, the idea here is not like to overload this converter. It's always like to operate with like less interaction with the AC grid as possible. So in terms of losses, would not be like a big challenge. But in terms of fault isolation, as you said, for a while, the industry feels like more comfortable to use an isolated solution. And why I was asking about EVs, we know now we are still improving in terms of like technology readiness, and maybe it will change in some point, and who knows what can happen with these installations. For a while, let's put in this way, the industry are feeling more comfortable to use isolation solutions.
It seems that with the isolation, with a single fault, the system can still continue operating. With a single fault, like a IT system that is used in very critical situations such as hospitals. But your three-part converter, however, it would not comply with this feature of having a single fault continue operating, because if the fault is in the transformer, everything could not operate anymore.
Yes, but if it's like a fault in the AC side, for example, we can still work only with DC. Where is like the main advantage of this solution? Here we don't need to process energy from AC to DC. We can like actually sounds like a very complex solution, but it's not. Why? Because here I'm only processing energy basically from this side, and we are avoiding to use it. So basically, I know there's maybe some limitations, but in terms of flexibility, there's a lot of flexibility here.
Remember that if you are not comfortable to speak in English, you can ask a question in Portuguese too.
Please, you can ask in Portuguese, Spanish.
Any more questions?
Em português? Meu nome é Hamilton, sou daqui da Universidade Federal de Santa Maria, e eu tenho uma questão relacionada à compatibilidade eletromagnética do sistema. Você tem diferentes cargas, diferentes conversores, operando em diferentes frequências, né, provavelmente. Variações de carga, e pode acontecer correntes circulantes aí entre cargas e entre as cargas e a própria rede. Então vocês têm já pensando, né, a topologia interessante, análise interessante, mas já pensaram alguma coisa sobre a compatibilidade eletromagnética entre as cargas e rede? Can be in English.
Não sei se eu respondo em português ou em inglês. Basically, the question was about compatibility between loads and the grid. Yes, this was like the question related to compatibility. In terms of compatibility, in terms of different devices, the main way is like operating under drop control. This is like the way how to share energy. But also in terms of standardization and protection, there are some standards related to EMC, EMI related to DC sources. So in this paper, we try to at least to indicate like which kind of standards we can use on it. Maybe we have like no standards for everything. But the idea was like maybe to use like the current standards that we have to indicate like some way to go. This is what I can answer for you. I understand that this is a problem. Maybe it needs like a selectivity and protection devices, but in terms of standards and how to develop it is not exactly developed yet. We have no single solution.
Okay, thank you.
And again, just to highlight something here, as I said in my remarks, we still have things to develop. This is a very important thing in terms of standardization. We really need it. We really need to ensure everything. However, this is also like a technology maturity. We need to go and work. The problems will appear, and we will develop more and more things. But just to highlight it, for example, this is a project of 7 million euro. So I just want to highlight how important it is, like for the country and also for the European Union. There is a lot of projects with DC.
Firstly, thank you, Edivan, for being here. I know that your travel was not easy as elders. Okay, not as hard as elders trip, but hard also. Thank you for being here, for coming for Sepoc. As you can see by my speech, this question is not so technical as the colleagues did, but it's more personal. Thank you for being here as a former PhD student from Sepoc, from UFSM. And for who doesn't know, Edivan will be at 4 p.m. in the discussion between the international students, who are former UFSM students, about the international experience. So thank you again for opening the doors of TalTech for UFSM students, because many opportunities of jobs are being promoted lately by PPG of UFSM through Edivan, because he is sharing with us this opportunity. I didn't know about Newton, but I'm happy for you, and I wish you success in these future paths. And I'd like to ask you if you have some tips, suggestions, recommendations for the students who are here, and in case they can be at 4 p.m. here today for this discussion, on which skills, which abilities should we develop to reach an international career and to follow your steps? Thank you.
Thank you, Igor, for the question. I don't know if it's like advice or what is it, but it's like my point of view, how it worked for me, at least. When I start to look like around the world about the research groups, about what people are developing around the world, I found like 2 or 3 groups who was working with like researchers, which was very interesting for me at that time. And why I decided to come to Estonia, I know Estonia is like a big country. It's not like a very famous country like another ones like Germany or even US, and another like you know, people from Brazil. We have like some like a point of view. We always like looking around for some like specific countries. But honestly speaking, I'm quite happy with like the selection what I made before. And why I decided to come to Estonia. When I saw the group, was a very well organized group, was a very active group. In terms of publication, they had like a lot of relevant publications. They had foundings, as I said before. And from my point of view, was almost 100% technical. In terms of country also, because Estonia is a very well-developed country, very well-organized country. The university is quite good. But for me, I was looking exactly where, at least I was feeling, where I could be useful. Who can really needs me there to work. And I think it was like the same case of Newton, because you know, partial power converters is not like, it's still a very hot topic. Still people are publishing. And for sure when he saw our publications, he was thinking to where he should go. And I know why, in this sense. So my advice was to select the place where you will be needed. This is the most important thing. This is a is a shortcut to improve your career, to develop things, to make things like faster. Sometimes people ask me, how you develop it so fast? I had like my merits, but because first of all, I select like the right group.
Perfect. Thank you very much.
Hello, Edivan. I'm so very happy to see you in this stage. Edivan was my student some time ago in the adaptive control course in your doctorate course, I think. So I'm very happy to see you. So I would like to do another question, more general question. How did you know this opportunity in TalTech? How? Where? For example, did you use some social media platform, emails, and other question? What advice can you do for our students here in abroad opportunities? Thank you very much for your presentation.
Thank you, Rodrigo. First of all, I quite happy to be here, but I also quite happy to be invited from you. And this was started in last COBEP when we was talking like between me, you, and Lucas. Lucas is like my close friend. We are still working with different collaborations. We always like talking each other, try to develop things. And this started with like a conversation between us, like in the last COBEP. And as you said, you was like you teach me like adaptive control. I always like remind things like we was like we are talking each other during our classes. So for me to be here, like invited by you, is like a great pleasure. Really, is a great pleasure. How it worked for me? Social media is, of course, it works quite well. I mean, I'm a IEEE guy. I active like in the IEEE in different paths, and the papers worked for me. When I saw like the papers, like the technical content, and I start to compare like my publications with their publications, I start to compare it, and I was start to feeling, okay, this group, they are developing things closer than me, and other ones. So maybe could be easier for me to move like for another countries. I had other opportunities to move to another countries, like US or Germany, but when I felt like they were working in a research topic where I really could to contribute, this was like the first step. After this, I know sometimes we are afraid to talk with people, like to introduce ourselves, to introduce our research, and how it works for me. I took like my publications, give to them, just to ask, could you read please? And when they saw what I was doing here in this university, in this research group, they like it, and we start to talk each other. This was like my approach. As I said before, one thing is like the publications. A lot of people worry too much about the numbers, about to publish a lot. But my advice is like to publish with quality, to develop real things. I mean, I'm working with hardware development, so I can have like physically something to show. This is also quite important. This shows like your background, this shows your experience. And my advice is to use all these opportunities, your publications, your prototypes, and in this sense, people will feel like you are like one interesting people to talk. It doesn't matter who it is. Could be me, you, or maybe like a huge name in Europe. If you have something interesting to talk, people will stop and will listen to you. This is like my, I don't know, but this is like the way I'm thinking.
Sound. Okay. First of all, congratulations for the presentation. It was a very interesting topic that you're presenting to us. My name is William. Again, I'm a PhD student here at UFSM. And I have a lot of questions like related to the modulation techniques that you guys are applying to the inner work that you guys are doing there in TalTech. But my main question I would like to do is, I'm not sure if you can share this with us, but who are the investors that are applying money like on this kind of research? Because nowadays AI is a very hot topic in with big techs like Google and Amazon. They're buying like nuclear plants in the US just for supplying energy to the let's say to the hardware applied on large language models, right? So they spend a lot of energy on that, right? So I'm not sure if they this kind of applications are included on the, let's say, on the menu of the investors. So again, who are the investors on this topic? They're looking for this these new advances on power electronics.
Just to complement a very small thing, you see a lot of people are talking about the AI for example, but have no idea how much we are wasting energy with data centers. So I was talking about electrification of, as I said before, almost everything. We are electrifying a lot of different applications, and people still do not realize how much energy we are wasting. This is one thing.
About investors, what are the companies?
Yes, sorry. So there's a lot of companies here. You see, in the current OS is like a consortium with different companies, and probably some of these companies they are not my sponsors. I don't want to advise too much, but there's a lot of companies. Even that now in Netherlands there is different companies startups developing the DC, and these huge names are starting to buying more and more these startups. So if you see the names involved in current OS, you will see there is a lot of money invested in it. And I did try to explain during my speech the reasons why. So there are public investments, as I talked a lot about European Union, but private company, there's a lot of private companies interested in people who really are developed. In our building, we have some partners like Schneider Electric and Eaton, huge companies developing some industrial developments, and basically what we are trying to offer to them is to compare our solutions developed in our lab and the industrial ones. So in this building we have both installed there, and we are trying to make measurements, because how to sell a new idea for normal people, we need a background, and what we are trying to do with this DC Innovation Hub is to create this background.
Thanks, appreciate it.
That's something really interesting that what you said, because if you want to put a DC grid on in a home, for example, you have to have, for example, a DC lamp, a DC air conditioner, a DC TV, and all of your device, well, the most part of them must be DC. Now I have one more question. What do you think that this adoption? How do you think this adoption will run? How do you think it will occur in for real people?
Yes, you see, if you look to current OS, there's a lot of the developers of power electronics, of protection devices, of power converters, and this question is quite good. One thing that we are really missing is other kind of industry who are developing appliances, and these guys should develop appliances for DC. We're still missing it. But what I'm feeling when we have better developed standards and showcasing it all the time and trying to push more and more, I think it will happen. It will happen. It will take time, but it will happen.
Thank you. Any more questions? Thank you for presentation, Edivan. We have some gift here. It's a reminder, you know, you lived here, but
Thank you for coming.
you can go with the win Estonia. Thank you. Thank you for your presentation. Então a gente finaliza os trabalhos do Sepoc desta manhã. Pessoal, lembrando que de tarde nós vamos ter a palestra do Dr. Everton e às 16 horas nós teremos uma mesa redonda aqui com a Geise Goulart, Guilherme Roeg, Edivan e o professor Saul será o mediador dessa sessão. Obrigado pela atenção de vocês, pessoal. Obrigado pela participação.